spanning tree algorithm. In this example, you could see you have all the vertices which could be like a machine, or the easiest example to think about, vertices could be like villages in a district, and you're trying to connect all villages together. In a way, you just want to minimize the transportation or the distances between those villages. Easiest example saying you are connecting all villages by phone cables. So you just want to minimize the distance of the cable used or the length of cable used in those villages. So we're gonna start, this is part of transportation. We're gonna start with Kruskal algorithm, minimum spanning tree algorithm. We're trying to connect all vertices V0, V1, V2, V8, as you could see here in this example, and we have the number, which are the way. It could be the distance in kilometers between places, or in meters between the places. It could be the number of units that must be transported between two machines, but the easiest example to be considered is the number in distance between two places. So the first point to consider, we're gonna sort the edges. This is an edge, and the way in a ascending order, in an increasing order. So we start with V7, V6, and the way is 1. Okay, V8, V2, and the way is 2. Meanwhile, I did actually pause the video to sort them in an increasing order, as you could see here. So we're gonna start with the minimum way, the shortest distance between two places. The shortest distance between two places is to be considered as follows. So we start with V6, V7, V6, V7. V6, V7, which is the way is 1. So we have, so the first two places to connect, or the first two villages, or the first two shops to connect between each other is V6, V7. So this one is correct. The second one, we go for V8, V2. And we always have to avoid forming a cycle. I will explain in a second. The third one, without thinking, is V6, V5. I'm going in this order. So V6, V5 does not form a circle, the red lines. And then V0, V1, it is 4. So now we have 1, 2, 3, 4. So edge of is 4, and then we have V2, V5, V2, V5 as well, does not form a circle. So V2, V5, now we have 5, I'm just counting the red ones, and V6, V8, would I consider it? No, because it forms a circle. So this one is no, because it forms a cycle, and I don't want this. This is the main reason of the main condition of Kruskal algorithm. Then we have V2, V3. V2, V3 is 7, does not form a cycle, so we consider it. V7, V8, so here we have 6. V7, V8, do we do it? No, because it forms a cycle, so we have to avoid it. V0, V7, do we do it? V0, V7, do we do it? I just need to double check this. V0, V7, do we do it? Yes, because it does not form a cycle. Okay. V1, V2, do we do it? No, because it forms a huge cycle, so we don't want it, so this is wrong. So in a way we have 1 2 3 4 5 6 7. So the number here is 7. Well, usually just write it at the end, you don't update it every second. And then we have V3 V4 V3 V4, yes, and then bingo, and we're done. In a way, why? Because we connected all places together. We connected all places together. So we have our minimum spanning tree, and the way of the minimum spanning tree is the summation of all those values. So 1 plus 2, this is like the easiest way to do it. 3, 5, 9, 13, 19, sorry, 3, 5, 9, 13, 13 and 7, 20, 28, and 37. So this is the minimum spanning tree algorithm with 37 as a value. Okay, so this is Kruskal algorithm, the easiest way to solve the minimum spanning tree algorithm. I'm gonna remind you how does it work. First, sort all edges in non-decreasing, well, increasing order of their way, as we did here. I have to remind you, the minimum spanning tree algorithm is Kruskal algorithm is simply transportation model, and it usually works when you have, like, you want distribution center, like you're distributing to a shop in a villages, or you're laying out the cable for the phones cable across the villages, and you want to minimize the distance, the length of cable you're putting in the ground to connect all villages together. So the easiest way to do it is to sort them in an increasing order, as you could see here by the way, starting from the minimum all the way to the maximum. Okay, pick the smallest edge, well, as you sort them, so you start with the beginning. If it form a cycle with a spanning tree formed so far, if cycle is not formed, include this edge, else discarded. Okay, so if it form a cycle, as you could see it here, you would not consider it. If it does not form, you just consider it. For example, when you were doing this, you never consider V6 and V8 because it form a circle here. So you just want to consider the one does not form a circle. You don't want it to loop as it form a cycle. So you don't want it to stick together as in a cycle, and there's no need for this. So because if you, for example, if you consider this line in a way 8 is covered, 6 is covered somewhere else, so this is like a waste of cable. So you want to consider the one does not form a cycle, and you discard the one, that form a cycle, and you repeat step 2 until they're all covered, as you could see here. Okay, so now if you want to consider this, we have 1, 2, 3, 4, 5, 6, 7, and 8. So the edge in here is 8. Okay, and this is very correct because we have 8 cities or 8 stores or 8 shops, as you could see here in this Kruskal works algorithm. After you form this algorithm, what you have to do is to run the same algorithm using Tora software. The Tora software is available on Moodle, which is the platform. So you just like feed the cities. We have in this example 8 cities, and you feed the way for every city as you see here, and you run the software. At the end, it will give you 2 outputs: the minimum spanning tree algorithm in this example, which is 37, and then it gives you as well the number of edge of minimum spanning tree is 8, and it gives you the connection, the easiest one, the shortest one between all the cities. If you try to link it in a different way, no matter how much you try, this would be by default the easiest, shortest one in all the cities. Okay, so please stick to this algorithm, and if you have any question, please let me know on the group. I will repeat really quick the minimum spanning tree algorithm. We have to minimize the length or the way of the edges of the tree. Okay, in this example they are vertices, and as we said, if you have a phone company, they want to lay down cable across all neighborhoods, across all cities. So the easiest way to do is to using this algorithm. So it will minimize the length of cable layout across all the neighborhoods, as we could see here. Okay, This is part of the transportation problem.